So sometimes people call the vertex the turning point of the parabola. It's where it changes, okay? So from decreasing to increasing or increasing to decreasing. And this one, the parabola is opening upwards like that. The vertex is right there. So that's where the vertex is. So this one is at the bottom. Take a look at the parabola graphed below that. What do you think would be the coordinates of the vertex in that one? 2 and 1, yeah. And so this one would be at the top. So when the parabola is opening down, the vertex is at the top. The axis of symmetry is the vertical line that goes through the vertex of a parabola. So, if you would, please, let's take this parabola up here. The coordinates of it are 4, -4, looks like. And let's go ahead and draw a vertical line through that vertex. Okay, that's called the axis of symmetry. The vertical line would have an equation of x equals 4. Vertical lines are x equals, horizontals are y equals. Okay, tell me what you notice about that line.
Over here, it only passes through the 1 point. It don't pass through both.
Oh yes, it only passes through 1 point, which is the vertex, yes.
It's staying in the middle of the 2 lines that go up.
Yeah. Do you know what the word symmetry means? Okay, symmetry means kind of like that it's the same on both sides, and so it's called the axis of symmetry because on either side of the parabola it looks the same. Like if you would have a mirror there, okay, it's like flipped over that mirror. So, and sometimes when we get to graphing in a couple days, we're going to say that if you know one side of the parabola, you can use symmetry to graph the other side. So, okay, let's move down to maximum or minimum. Now this is kind of a trick question because the maximum or minimum, you're gonna see, is the same as something else. The maximum is the point of the parabola that is the highest. There are only certain kinds of parabolas that have a maximum. The ones that are opening down have a maximum. This is the highest point of the parabola. What is another name for it?
Maximum.
It's also the vertex, exactly right. So the maximum is also going to be the vertex only when the parabola is opening down. So sometimes when I ask for you to find the maximum and you're like, wait a second, what is that? It's the same as the vertex on a parabola that opens down. Okay, what do you think the minimum is then? Yeah, it's the lowest point of the parabola, and it's the same thing. So right over here, it's the lowest point, and it's the vertex when the parabola opens up. Any questions so far? Okay, hey, let's back up. What would be the axis of symmetry of this parabola here? Yeah, x equals 2 would be the axis if I wanted to draw it. And how about this one would also be x equals 2, wouldn't it? Okay. X-intercepts. We've actually learned about x-intercepts and y-intercepts before, and they're not anything different. The x-intercept is going to be, and actually sometimes there's going to be more than one. So I'm going to write the point, and then in parentheses I'm going to put a plural or points, because sometimes it can be 1 point. and sometimes it can be 2 points, and sometimes it can be no points. I'll show you how. I'm going to show you some pictures. So it is the point at which the parabola touches the x-axis. This can occur once, twice, or never. Okay. These are also known as the zeros of the function. Hi. Thank you. The place in which f of x equals 0. Okay, so actually another name for x-intercepts, I'm going to put all 3 names here. Zeros, because it's where it hits the 0 spot. It's where it hits the y equals 0. And then some people call them roots. So write those 2 vocab below. Those are 3 words that mean the same exact thing. X-intercept, zeros, roots. Okay. Now I need you guys to help me out on this. This is a parabola that has how many x-intercepts? You can say it louder. I hear ya. 2. Here and here, right? So sometimes it happens twice. Can somebody help me or tell me how would I draw a parabola that has 1 x-intercept? Santos, what do you think?
Sideways, diagonal. When we flip it.
Oh, you know what? That's a good. Can we talk about sideways parabolas in a second? Because you're right. We're not going to talk about them in this class, but they do exist.
Oh.
So this is going to be just up and down ones. What do you think, Aiden?
If like the vertex starts on the x-axis.
Yes. One time would be if the vertex is on the x-axis. So would you draw a parabola? I'm going to do an opening down, and would you make the vertex just be on the x-axis? So that would be an example of 1 x-intercept. So this is twice, 2 x-intercepts, 1 x-intercept. That's my abbreviation, x-int. All right, last. How would I make it not touch at all? Any ideas? Go ahead, Aiden.
Just a lower line, so that's lower line.
So you want me to make the vertex down here?
Yeah, and it goes down.
Oh, and make it open down.
Yeah.
Or if you had the vertex up here and you made it open up. So then it doesn't touch at all. Okay. If I had the vertex up here
Oh.
and then I made it open this way, yeah, it wouldn't have an x-intercept.
Can one line be bigger than the other? Does that have to be
Wider, you mean?
yeah, whatever.
The parabolas? Yes. We'll talk about what makes it wider and narrower. So Santos brought up sideways parabolas, and they do exist, but we're not going to talk about them because those are not functions. We're not going to talk about them in this class. In Algebra 2, no, in Geometry you might talk about them. Don't copy this down. Just look. Why would that, let's see if you can remember, why would that not be a function? There was this test we used. Good memory. The vertical line test touches more than once, right? So this couldn't be a function. This is something. We call it like a quadratic, but it's not a quadratic function. So we're not going to talk about those in Algebra 1, but they do exist. Okay, let's see how you do. Would you take a moment, now that you know this vocabulary, would you look at this parabola and would you tell me or answer what these things are? Give me the coordinates of the vertex. Is it a max or a min? Tell me the axis of symmetry. Would you list the y-intercept and x-intercept, please? For the vertex? For the vertex and the axis of symmetry and the y-intercept and x-intercept, yes, I do. And also for the x-intercepts, you're going to have to approximate, it looks like. I think I know what they are, but I'm not sure. Okay, that's what I got. So I got 1, 2 for the vertex. It's a maximum. Max is, hopefully you know my abbreviation for maximum. Okay, so the axis of symmetry is a vertical line that goes through here. And so the equation for that line would be x equals 1. We didn't talk about y-intercept, but the y-intercept is just the point where it touches the y-axis. So it touches at 0, 1. I don't know for sure because there's not a scale in between what these are, but it looked to me that the x-intercepts were negative 0.50 and 2.50. So those should have zeros on it, not numbers. What's that? What I'm saying is if they are where they touch the x-axis, then the coordinate should have a 0.
How did you get 0.5?
I circled right there, and it looked to me like it was about halfway between 0 and negative 1. And then this looks to me like it's halfway between 2 and 3. Okay. We are going to just finish today by graphing the parent function. The parent function is the most basic function.
Is this going to be on a pre-SAT?
Quadratics are on your PSAT, yes.
When
Okay.
When we're done with this, you can tell us what's on it. Or like the general concept of it.
Yes. A lot of what we've done in this class. So, when you square something, little reminder, that means you're multiplying it by itself. You absolutely can use a calculator, but these ones we're going to do on our own. Also remember what happens when you multiply a negative times a negative. It becomes a positive. So, the most basic parabola is y equals x squared. So all I'm going to do is I'm going to put in some x values and we're going to plot the points. So negative 3 squared means negative 3 times negative 3, so it's 9, so that would give me the points negative 3, 9. Let's do negative 2. What is negative 2 squared? 4. It's positive 4 because a negative times negative is positive. So this is the ordered pair, negative 2, 4. What's negative 1 squared?
Oh, squared?
Mm-hmm.
2.
Negative 1 times negative 1.
Oh, yeah.
1. So the ordered pair is negative 1, 1.
How are these positive? It's only one negative. I'm confused.
A negative 0 squared. What's 0 squared? 0. Santos, I'm writing an ordered pair, so what I put in was negative, but when I squared it was positive. That's why this one's negative and that one's positive.
Oh, okay.
1 squared is 1. So what you're going to notice is some of these outputs are the same, but this time the input was 1 and the output was still 1. So these 2 points, that's where it's symmetry. You're going to see when we graph it. What's 2 squared?
4.
4. And what's 3 squared?
9.
9. So I'm going to plot my points. So -3, up 9, -2, 4, -1, 1, 0, 0. And now it starts, this is going to be my turning point. 1, 1, 2, 4, and 3, 9. And you have to be smart and know that these are not two lines coming together, okay? Because the rate of change changes. You're going to do your best to draw a U-ish or a curve through those points. Okay, does that make sense?
Sensation.
You're not going to be asked to graph things quite yet. You're going to just look at graphs, but I wanted to show you the most basic parabola there is. We call it the parent function. We do this in math because sometimes we have a family of functions. They all look kind of the same, but this is the most basic one. Okay, it's centered at, what's the vertex on this one? 0, 0. So the vertex is 0, 0. Somebody tell me what the axis is.
What?
X equals 0, right? Is it a maximum or a minimum? Good job. I always write y opens up. This is interesting because x-intercept and y-intercept are the same, because doesn't it touch at 0, 0?
Yeah.
So it touches the x-axis at 0 and the y-axis at 0. Very last thing is not a super big deal, but we should tie it into domain and range. Domain is all real numbers because it can be anything. Didn't we input positives and negatives?
Yeah.
Yeah, but what came out? What kind of numbers? Only positive numbers. So the input, the domain is all real numbers. The output is positive numbers. So we were going to say y is greater than or equal to 0.